And today, because first period got shortened, today I'm videoing. Normally I will not be videoing your period, I'll be videoing first. So today I'm confined just to this board right here. But tomorrow I will be able to do that. Okay. All right, so today we don't have much time. So we're going to look at a pretty simple topic, but one that's very, very important for us going forward as future calculus students. When I draw a number line, and I put an open dot here and an open dot here, and I color in between, everybody knows what that means, right? That means all the numbers between 4 and 7. That does not mean just 5 and 6. That means all the numbers between 4 and 7. If I wanted to write that as an inequality, I could do it like this. Would you agree with me?
Yes, ma'am.
That would describe all the numbers between 4 and 7. Please note that when you write a compound inequality, and that's what this is called, a compound inequality, the symbols are always less thans, or less than or equal to. You never put greater thans in an expression like this. You always put the first number first, the second number second, X right in between them, and those are less thans. Now you know, if I color in the dots, the only thing that would change when I wrote my inequality is what?
It'd be greater than, or less than.
It'd be equal
Maybe, or equal to. So I put my 3 here, I put my 10 here, I put my X in between, and then they're going to be less than or equal to. All right, now so far I haven't showed you anything you didn't know. You already knew that, and you're sitting there thinking pre-cal's so easy. You're right, it is. But here's something that you may or may not be aware of. In your calculus class, you know, once you get out of high school math, we really don't see things written this way. Instead of writing this set of numbers between 4 and 7, instead of writing it this way, we would write it this way or this way. You'll see it both ways, so I'll do both. I'll use this one predominantly, but be aware this means the same thing. This is what we call open interval notation. Anybody want to take a wild guess why it's called open interval? Take a look at what it's suggesting.
Because the circles are open.
The circles are open. Yeah, the circles are open. It's an open interval. So we're talking about all the numbers between 4 and 7. We're going to write it this way. Now, this one, guess what this is called? A closed interval. And your closed interval notation is brackets. So when you see these brackets, you know that represents that the endpoints are included. And when you see the parentheses, you know the endpoints are not included. So all of this describes the same thing. These are 3 different ways of talking about the same set of numbers. Likewise, 3 different ways of talking about the same set of numbers. So let's say you leave this class and you're walking down the hall and you find this. What does that mean, do you think?
It means one's closed and one's
And not just one is closed and one is open, but particularly the 3 is closed and the 4 is open. Okay. So let's suppose you head down another hallway and you find this. What would that look like, do you think, in interval notation? What would that look like? You know what it looks like on the number line, right? Okay, that'd be an open dot at -4 and shaded this way. Everybody okay with that? How do you think we would express that as an interval? Yes, Maria?
just a -4 in close parentheses.
-4 with the parentheses, like this?
Yeah.
That's an interesting idea. Okay, it's not the way we do it. But it's an interesting idea, interesting. I guess my question to you would be,
How do you tell which way it's going?
yeah, how would you know which way it was going?
Just on the side.
Yeah, I don't know. Anybody have another thought? She's halfway there. She is halfway there,
Oh,
for
that's
sure.
what I was gonna say.
Wouldn't you do a parenthesis and then like negative infinity to negative 4?
Have you seen the infinity symbol before?
Yeah.
This is exactly the way we do it, Mr. O'Connor, is it? This is exactly the way we do it. Negative infinity to negative 4.
So smart.
Now, one technical point. And remember, sometimes Mrs. Ford doesn't get to make the rules. Sometimes I have to follow the rules that are established by other mathematicians. If we had this, let's say, I don't think it's too much for you to think this is going to be 4, comma, positive infinity, right? But that symbol right there is always open. No matter what the symbol is in the problem, the infinity is always open. Anybody want to take a wild guess why that is? That's a hard and fast rule. Do not mess with it. Anybody want to take a guess why maybe that's the case? Can you ever color in infinity? Can you ever get to infinity and color in that dot? No. So this indicates you just keep going all the way up to infinity. Super. Any questions about that? Tonight you'll be going back and forth between the various notations. All right, next. Next. Oh, by the way, in Schoology, when it says P1, that is what the first section in your book is called the P chapter, the prerequisite chapter. So that doesn't mean page 1, that means section P1. I never put pages in there, I put sections. So section P1 is what we're going over. Okay, yes. And you gave it for my book, if you need to, it's got the answer.
Grace, you start base. You started with it.